Hi, I'm Michael Joy. Welcome to another reaction video. And actually, this is another mold making video. So you're going to start hearing me say these are hand-ufacturing videos because this is the platform that we're launching. I'm a professional mold maker with over 30 years of experience in, I don't know, maybe 12 different industries. So very diverse background. And what I found is that watching other people make molds is a great way to teach. Sometimes I talk a lot, sometimes I talk a little based on the skill level of the video itself. Kay introduced me to this guy. He runs a tight ship. This is Making Molds That Make Molds. And Kay liked this video because he's like, I don't know what this guy is talking about. I watched about 5 minutes of this video and I'm like, okay, I see what's going on. There's a few things that I would like to talk about because I think this young man is on a great journey, and I noticed that he was kind of having these design epiphanies that I also experienced as a young mold maker, and they're really, really like unlocking part of the way of thinking. And so I'm going to get into this here. I'll probably talk a little bit more about things that I don't usually. What's happening is that I realize that the type of person that's watching this video is really, by the time you're watching this, you're into design, you're into manufacturing, you're into mold making, and I can have a different type of dialogue. In our platform, Hand-ufacturing, I'm not going to be teaching this type of mold making. It's just not as common. I'll talk about it, I'll reference it, I'll teach through videos, but I'm not going to tie up my shop to make videos. And we have a shop that does all this stuff. So here we go. You ready?
You'll know that I'm documenting the process and workflow in creating the wireless charging stand. The next stages to this will be creating a matrix mold for the front section so I can do some resin cast versions and also some batch printing of the other components. I'll be printing the shells and the components on the Hagears Ultracraft reflex printer. The mold shells will be printed from their PAWR10 resin.
It's nice how detailed he is. I'm sure there's sponsorship issues. We used printers, not this brand, and we kind of outgrew them really fast. They were not reliable. Hagears, like I said, this is not about Hagears. This is another company entirely, but it was the stereolithography process, which is the laser printing in photosensitive polymer. And I'll talk about that more in detail. Let's see if his equipment, he's doing this contemporary. Me was years ago using this equipment, so I'm sure it's gotten better.
Which is a strong and durable resin, ideal for something like this that'll see some heavy usage over time. I'll switch that out to the PAU10 resin when it comes to printing the components. So
if you don't have a printer like this, none of what he's saying makes sense, but they're great to have reference points because you'd be like, oh, who was that guy that built that so-and-so? Let's go hear what he says. And you know, let me see what he's doing.
Just to sum up where I'm at with this, I've backtracked and changed some of the processes to make these. Because I've done that, I've had to do some design changes to accommodate, but it's all in an effort to try and improve the efficiency of making them. So before, the stand was made up of 11 pieces, which all slot.
I don't know what he's doing here. It's his world. I'm not dismissing what he's doing. I'm just speaking to it from a design standpoint because he experienced something that a lot of designers experience, and that is there's an enthusiasm of design to appreciate something done perfectly, and it's a very additive process. Oh, let me do this, and I'll add this, and then we'll put this feature in, and then this has to lock to this, and it goes on and on and on. But there's a point where it tips, and it says, oh, wait a minute, I've over-designed this. It can be more simple. I actually don't need this. Now that you can see all of the complexity, these pieces can start being pulled out and going, I didn't need that. I didn't need that. People who love design often overbuild. I had a guy who was a genius on our team, and he would just over-design things because he loved design. And then I'd be like, wait, bro, we gotta bring it back. It's kind of like I always used to say, it's like building a crane to move a big rock when you could just go get 4 guys to help you move the rock. You know, there's simple solutions. His may not be that simple, but it's a concept worth discussing.
Slotted together, magnetically attached. Design-wise, everything worked and went together well. However, as I got to the point where it was time to actually make them, it dawned on me that there's a lot of components per finished piece for me to manage on my own. It'd be so labour-intensive to create them and just not practical from that point of view. Just because I design them as individual pieces doesn't necessarily mean that I have to make them that way. So I went back and I've combined as many pieces as I can, just to try and slim everything down. So I've now gone from 11 components down to 6, as well as reducing the amount of hardware needed to assemble them.
This is the thing, is there's sometimes designers aren't thinking about scalability. If he's making a prototype for a project, for a film, it's a whole different dialogue. But if you're an industrial designer making a part that has to be manufactured, there's many times that there'll be a prototype built in a shop and then it gets sent out for manufacture. And then manufacturer guys are like, you didn't need this, you didn't need this, you didn't need this. It gets stripped down for production because the cost becomes extremely prohibitive to build a design exactly the way you want it. Now, it's possible, but I have this short story. I was working for, I can't say the name, it was a global chocolate company. And the designs that they were asking for, they finally just decided, let's hire a mold maker who's creative to do the design work, because what was happening is they were hiring these designers to design their chocolate pieces, but then the designs of the chocolate pieces would go to the mold maker later and they'd have to redesign it anyways. And they're like, I paid this designer for a design that doesn't get moldable. Let's just have a mold maker design the piece if they're capable. There's a lot of mold makers that aren't good designers. They're good craftspeople. It's not often that they overlap. This guy seems to be, he's in the world of overlapping design, manufacture, and mold making.
So this is the version from the previous video. So everything that makes up the back, which is 4 pieces, will now end up being one solid cast part. The charger holder and the magnetic version will have the insert trim attached to it. That means that I don't have to have the little magnet holder that was behind there. That's another part taken out. The front will remain the same, other than just a slight functionality change in actually making the mold, but also to have a system where if I...
This is nice that he has things to show, because what happens, what I've experienced is there's a certain level of mold making and design that you can't talk about it. You got to show it. And even sometimes when you show it, it doesn't make sense to somebody who hasn't made the molds before, because mold making is about seeing the negative space first, not the positive space. And a lot of designers start with the positive and then they get to the mold. There's a point in mold making where the epiphany happens. It's like, wait a minute, why am I designing from the beginning? I need to look at the end first and then design backwards. But it's not easy to do if you don't have a lot of experience, because how do you know what's at the end of the trail? So I see him discovering some things here.
I wanted to make multiple versions of this mold to run at the same time. It's quick and easy for me to do with minimal setup. So I've made a mock-up of what I would normally do.
Okay, I get it. So what's really happening is he's creating molds that make molds. We call them master molds, but there's actually another level above that called an omega. And it depends on how fast you need to scale your production. And a mold that makes a mold with limited setup, it's a master mold. It's very common in artisanal mold making. I'm glad he's got this. These small stereolithography machines are great in the sense of that now on a desktop you can build something terrific. I don't remember the name of the machine we had. We bought a couple of them. We were super excited and we had some great success with them, but the print fails are really a bitch, because you wait overnight, you got deadlines, and the machine is tied up, and you come back and find it failed, and it was too late to go back to the shop from the alert the machine sent you. And then we had trouble dealing with the company itself. We would talk about these issues, and they had so much proprietary stuff that they could only resolve in programming and upgrades of the machine. It was like, come on, man. Also, the resin became very expensive. There's a lot of parts washing afterwards. You pull this out of the print bed, then you got to clean it, deburr it, all sorts of stuff. Now, it's great for certain things that you can't machine, but it became very tedious for us, and we really found just better filament printing machines that were faster. And for our workflow, we were printing things that didn't have to have perfect surface finish, because remember, we're a food shaping company. So the food was very forgiving of this, but these machines, I'm not the expert on. I just know that they kicked our ass in the day, and it was so frustrating. You're also limited to scale on these machines. You can only print certain components, whereas the filament printers, you could deal a lot bigger. Now look at him dealing with this resin. The resin is terrific for what it does, but I'm a guy who thinks about the material flow in the earth. You throw out, if you're a shop and you're throwing out a lot of containers of stuff, it's just like, I gotta stop this, you know? You gotta cure out the resin, then throw it out. This is photosensitive, so how do you cure it out? And stuff starts getting in the waste stream and it can be contaminated, and it's sticky mess, and I don't know, for us, it was...
those parts and get another batch print going. Ideally, the printer should be continuously running.
Ideally. They're beautiful to watch. Okay, so because this guy is really good, I'm going to talk about a lot of things that I won't really talk about with other people because I just don't have the platform for it. First off, it looks like he got a bigger vacuum chamber, or either he started pressure casting. His other chamber was way too small, and he was actually degassing material in it. And if you do that, you tie up your chamber because now the silicone, what you need is a big enough chamber to put another bucket inside and degas that whole setup. I don't like his workbench. His workbench should be stone. At this point, it's an easy surface to clean. What happens is you get resin and things on these surfaces, and then they begin to create issues. Also, the stone table, once you level it, you're done. Wood warps and shifts, and your table can come out of level.
The amount of prep is so minimal with these. All I need to do is glue in what will become the pour hole for the cast.
So if you're using platinum cured silicone, the glue that you use is very touchy. If this is just a super glue, that super glue off gases. So if you glue something and then you right away pour your platinum cured silicone, the fumes from the glue are going to inhibit the cure of the silicone, and then you got this gummy spot. So we would glue with super glue, but we knew to wait an hour or two before we poured on top of it.
In the resin into the back, which is a piece that I've also printed. Then add the sprues for what will be the air holes through the mold using these 2.5mm dowel pins.
To me, this is overbuilt.
So I've really tried to think ahead with all the features that I've added to the mold and the master, just to try and make the mold making process as straightforward as it can be. So rather than gluing the cotton buds on like I normally would, I think this dowel system is going to work a lot better for efficiency, and it's just a clean method as well.
It's nice, those pins drop out. We used to put in temporary vents as well. It's a handy trick.
So it's probably something I'm going to use moving forward on all my other parts. On the front side, you've obviously got the dowels as well, but those aren't air holes. So this is like the forged carbon mold that I did. So these will create a void through the silicone like air holes.
Yeah, silicone, you don't have a shot at it afterwards. Once you make silicone, making a nice hole in silicone is really, really hard to do, if not impossible. You can drill certain silicones, but you got to make the negative space right from the beginning.
But what they're actually for is so I can put an M3 machine screw through the shell and put a threaded insert on the end. So when I pour the resin in, the resin will go around the insert, encapsulate that in, and again, it just saves me a step in post-processing where I'd have to glue that in.
See, all this doesn't make sense to a lot of people, but he's just describing what has become obvious once you do something. The thing about mold making is it feels like nothing's obvious until you do it. And it's like, what the fudge? You know, how did I not see that? It's not an intuitive process. It is a try-fail process. Try-fail, try-fail. Hopefully you have a mentor or something to shortcut this down. It's not the way I rolled, unfortunately. That's why it took me so damn long. And gloves are okay. He doesn't need them at this point because any surface of spray that he's disrupting, it's disrupted with gloves or your hands. It doesn't matter right now. It looks good on camera.
Them together with the M4 machine screws.
I'm not sure why his case is so fancy like that. We'll see.
Prints align well and close up tightly, so I don't think I need to worry about any silicone leaking through at the split line.
Mm-hmm. That's fancy.
I've also applied some filleting wax to the 4 dowel pins that come through the shell, just to ensure they stay in place.
Good idea. So, to me, this is a basic mold making thing. I don't know if he's doing it for his camera or not, but he's setting up to pour on a work table. You set up to pour on a work board because now all of a sudden, if he's leveling something, he's got a closed case, so he can move it around. But imagine if you set up your piece right there, you're locked onto your work board. You can't move, you're locked onto your work table. You can't move around. Always have a place that you pour and then a place that is where the material cures. I'm being a little rough on him here, but I think it's just for the camera.
So
it won't matter, his case is
the
closed.
mold that I made in the last video. So I've propped it up at an angle, putting this corner at the lowest point, which is where I'll pour the silicone in, and this corner at the highest point.
Yeah, we used to call these blanket molds, and they were always much larger. And when you get into a larger mold that you're filling a negative void, the hydraulic pressure is intense. And he doesn't have that concern, but even with small amounts, that seepage is a direct possibility.
Which will be the last exit point for all the air inside the cavity. Mm-hmm. So when I pour the silicone in, it'll come up the mold at this sort of angle, coming out of these air holes as it goes up, and then it'll converge at that last point. So having that.
If your air holes are too deep, you can lock your mold together in a way that causes you some grief afterwards. The air holes that I like to make would be tapered rather than vertical drops. If they're tapered, it releases from the case much easier.
At the highest point, just stops the chance of any air trapped between the silicone and the underside.
You have to have something ready to stop the weep, because as he fills this, the silicone's going to rise up out of the bits here, and you got to be able to plug that with wax or something, or else it just keeps pouring out.
Side of the shell. The silicone I'm using is a Shore 28A.
Okay, let me stop right there. Again, I said I would harp on things. Every digital scale that you use for mold making should be in a plastic bag. What happens is the digital scales get goopy and guppy and yucky and everything like that, and they can get less accurate. Plus, it's just messy. He has gloves, but if he touches something, he's putting messy gloves there. So bag your scales, put a hole in the back of the bag for the power cord if you're not on battery. It's just standard practice.
Addition or platinum cure silicone mixed at a 1:1 ratio. Because I designed the silicone mold as a 3D model, I was able to look at the model properties to see the exact volume.
Again, small things that I want to talk about. If you're buying silicone that is opaque on part A and B, you need to add a little pigment to it, in my opinion, because what happens is when you're mixing two opaque colors together, you can't tell if you've really worked the A and B into each other. But if you have a color, you'll see the color change become uniform, and it's a real nice way to make sure you've well mixed your material.
Volume of each cavity, enabling me to calculate the amount of silicone needed. I always like to add some extra, just to account for the residual silicone left in the cup after you've poured.
So he has a nice mixing stick. That mixing stick is perforated, and it allows for the folding of the material nicer, but pigments would help as well. Mixing sticks are always too small.
I'll give this a thorough mix.
So he set down that stick. Again, I'm being hyper thing here, because if you're in a shop, all these little things add up into time. I know his motivation is not the same as my motivation, but I would have had a small metal tray for that mixing stick to be set down into, because now he's got wet silicone on his work table, and it's created another fly trap of issues.
Making sure I scrape the sides and the bottom of the cup.
There we go.
Then I'll degas it. This silicone is relatively low viscosity, so doing a stretch pour where you pour a thin stream from a height will collapse a lot.
The stretch pour we always called needling. And you don't have to do it when you degas silicone. What you need to know is you have to have a big enough volume of container. If you have this much liquid silicone, you need to have 4 times the empty space in your container, because what happens is as that degassing happens, the silicone loafs and rises like you saw, and he was probably controlling the valve just to drop it, to bleed it right before it overflowed. You got to have a big enough container, else you got to bleed a lot, and it extends the time for de-airing.
In the mixture if you don't have a vacuum chamber. It's a method I used when starting out, when I didn't have a vacuum chamber, and it's proven to work really well.
The other thing is you saw how he reached in to grab the container. Because the silicone rose up all the way to the top, he's grabbing liquid silicone now. Another thing, it's just silicone gets everywhere.
I'm pouring this in at a relatively slow rate. If I was just to dump it all...
What we would do is we would create an external pouring gate on our cavities, because you gotta sit there while it piddles in. But if he had printed a little bit of a custom funnel, he could have logged this in and then it would have distributed, and now he's tied up. When we do big blanket pours, we used to tie buckets from the ceiling because you'd be sitting there just slow and it just gets fatiguing. This is, he's not pouring 10 pounds, he's just pouring, half a pound.
That will just increase the likelihood of getting air traps. I want the silicone to flow freely and slowly through the mold, finding its own way all the way up to that last air hole.
Yeah, good.
As the
I like the little
up,
yellow, it's cute.
I can block the lower holes with the filleting wax to stop them overflowing. Now these are done, I can wait for them to cure.
So in silicone, there's a couple ways to accelerate the cure. One is to use a short pot life, which is dodgy in this instance. The other is to have a warmer environment. So you could have in the sun, put your mold in the sun. Don't do it right away. You have to let that air rise out, and then you can heat it a couple hours later. If you heat fresh silicone too soon, it expands and it'll not capture the detail you want. You disrupt the pour. But I would set this now out of my way so I can use my work table again.
So while I'm at this stage, it makes sense for me to get this mold poured. So this is a multi-cavity mold, which is essentially 4 masters built in. It's very similar to the other two, where it's a mold to make a mold. All I have to do with this is pour silicone in, and then that's done. I can just take that out and just keep doing that based on how many molds I want to run at the same time. So functionality-wise, this mold's exactly the same as the previous rigid printed version. So it's still got all the same features with the locator points for the rigid piece that goes in. To achieve the finish I want on these parts, I've shot blasted the entire piece, same as I did on the original mold, which will give me a nice grainy finish.
Oh, he wants that, okay.
After degassing the silicone, I can start pouring it in. I'm only partially filling the mold to a point where the silicone is covering the details on the master. Usually at this point, for something with fine details, I'd get a small paintbrush and brush those details.
You don't need to do that. What happens is if you use the small paint brushes, sometimes those brushes shed and they'll end up falling in the silicone, and you never, in my opinion, you never want to bring anything into the mold afterwards. You could use compressed air, but the fact that he's degassed his silicone, he's good. He doesn't need to. If he was worried, if he had detail that he was worried about, on his CNC, he cut a vertical channel. All you have to do is pitch that channel that you cut, and the silicone will run into that, and it won't trap air. In fact, he's pouring so thin over the top of his detail that there's not enough head pressure from the silicone to push into that detail. So you have to have a high viscosity silicone to flow into that. Otherwise, you have to pour a lot of silicone on top so it presses into the detail.
Areas, essentially dislodging any air trapped in those details. In this case, I'm going to put the entire mold in the vacuum chamber.
He already degassed one time. When you put an object into the degassing chamber, what happens is now you have to level it in the chamber, and plus it's likely to overflow inside. And I did this once and was like, what am I doing? I'm just making a mess for myself.
Even the same, or if not, a better result.
No, you get the same result.
Once
I've
that's fully degassed, I can take it out, fill it up to level, and wait for that to cure as well.
Extra steps. If you're selling your time, you don't want this step. Put it on a workboard, put it on another table, level it, shim it, and you're good. Do you see how his table could have micro textures on it from resin pours, and now things sit wonky on there?
As I'm waiting for those to cure, I can remove the first batch print and start prepping them. I'm only prepping these as far as the curing stage. So supports removed, components washed and set to cure.
It's an easy sentence to say, but it's a pain in the ass to do. He should have spilled his parts out onto a piece of foam. So whenever you have this chemistry and washing, it looks really easy to do, but that ultimately gets dumped somewhere. So this parts washing from the SLA process is now he's going to do a UV cure. So you can see on the equipment all his fingerprints from probably handling it with other silicone things. What happens is if you're the master of your own shop, this is okay because you blame yourself. But you have staff that does that and then they gum up, something happens on the threaded rod there, the screw.
I want to build up a bit of a prep pile so I can tackle the sanding.
This is nice. He has a raised table. A lot of people don't raise their benches and they end up working like this. All the tables in my shop were high because I'm 6'2", so I wouldn't have to bend my neck.
Of the printed and the cast parts all in one sitting. Now these have cured, I can start demolding. This is a case of driving a wedge between the two halves.
You don't need gloves to demold. Actually, the thing that you want to be very careful of is that the silicone, when you open a mold like this, now this is for people working with platinum silicone, which is touchy. Platinum silicone takes longer to cure. And what will happen is, in the thick spaces of the silicone, it cures very nicely, but in the thin spaces, it does not. And so you open the mold, and then if you put your hand on the seam line of the mold, it's still gummy. And now what you've done is you've embedded your gloves or your finger with fresh silicone. And then if you touch silicone, it bonds. And now you've transferred and laminated your own fingerprint into your brand new frickin' mold. It is such a bummer to find out. So you got to let these totally cure.
Removing the two masters and pulling all of the dowels out.
You don't need gloves. See this taking and throwing? It all adds time because now you got to go back and get that. If you just have a small tray, I would have a little tool bin right there, just a little tray. And when I was done with the tool, I'd put it in the tray. That way I pick up the tray and I walk to the next place and everything's there. Now I'm looking for that damn pin because it fell behind the table. Never toss things on your table.
It looks like the pour's been successful without any air traps. I can now turn these over and trim off the excess silicone on the back of each of the shells.
Did you see how dirty his scale was?
Yeah.
Yeah. Now it takes time to clean that.
Then remove
I'd rather
the
go
silicone
home than
and
clean
trim
my
off the
scale.
excess from the air holes so it seats back into the shell properly.
So the other thing is when you're working with this translucent silicone, it's harder to see flaws in translucency. If you pigment your silicone and you have a dense color, the flaws stand out much easier.
Now I can move over to the multi-cavity mold. Degassing the silicone inside the mold has worked really well.
Don't need it.
As all of the small text and details have got zero air bubbles.
See how he's searching in the translucency? If he had the colored silicone, you can see that small micro raised text really fast.
Before I screw the two halves together, I need to insert the machine screws and the threaded inserts. I'm filling the threaded inserts with filleting wax to act as a barrier so no resin can get inside onto the threads. So in the exact same way I did for the forged carbon mold, I can push the machine screws through the silicone, revealing a small.
This is where I'm talking about that goopy fingerprints matter. He's handling, I think I'm not sold on what he's doing with these threads, but he must have a good reason.
Portion of threads on the inside of the mold. Then I can thread the inserts on. The machine screw will push the excess wax out of the back of
Could you imagine having to do this again and again?
the insert. So once they're all in, I can cleanly level that off. I'm propping the mould up in the same way as I did when pouring the silicone for the exact same reasons. I'm casting these parts using polyurethane resin that I've added black.
Again, put your scale in the bag, you can see it right there. I mean, once his buttons get gummed up and the screen for the reed is already interfered with, it's not great.
I'm also adding 10% milled carbon to part A for additional strength in the part. This resin doesn't strictly need to be degassed due to its low viscosity. However, when I use milled carbon, I will always degas as part of the mixing process before adding.
Well, anything that it has porosity or absorption to it, even though I don't know a lot about carbon, I didn't dance with that, but I sure would have worn a mask. And what happens is each particle of anything dry is encapsulated with air. So the resin, you need to give time for the resin to kind of bust through that bubble and to saturate whatever dry ingredient you're adding to it, whether it be pigment or carbon, which I'm about to learn about.
Adding part B. If it's not mixed thoroughly, you can end up with very small clumps of carbon and part A that didn't mix into part B. Usually I'd put this in the pressure pot up to the point where it starts to gel, but I want to run a test just to see if that is needed as part of this workflow.
You should always pressure cast. Pressure cast parts are not only, you're more guaranteed of a higher success rate, but the pressurization creates a denser urethane casting, and so you have a stronger part due to the pressure. But you only need to go to, maybe 40, not more than 60 psi for sure. 40 is a great pressure.
While I wait for that to cure, I can go back to the printer and run another batch.
I wonder what his print time is on that.
These parts that are finished are the inserts that go into the multi-cavity mould to be overmoulded. There's actually no prep work needed with these. I still need to wash and cure them, but as they're being overmoulded with resin, they don't need the support remains sanding off.
Overmolded with resin. I remember building things that were so complicated and there was such pleasure in it for a while. And then I'm like, I gotta get freaking smarter because I'm never gonna see my girlfriend.
The resin I'm using for this again is a polyurethane, but it's a flexible version with a shore rating of 30A.
That's semi-soft, yeah.
I'm adding my black pigment to part A, giving that a good mix, and then adding part B.
So a lot of people mix like this, and overall, mixing sticks are too short. What it does is it brings your hand down into the cup, and always a mixing stick that is like this allows you to turn the cup and stir. If you have a short mixing stick and you're trying to get in there, your materials then hit you. It sounds like a small thing, but don't settle for these short little tongue depressors when you have a deep cup like that.
This resin again doesn't need to be degassed, but I would recommend it as it vastly improves the structural properties of the cast part.
Okay.
I would usually put this in the pressure pot as well because of those fine details.
I would.
But as this resin takes a while to gel.
The thing about pressure casting is if he had not de-aired his silicone, he could not pressure cast with it. If you pressure cast resin into an unde-aired silicone, it gets pimply because there's air bubbles throughout the silicone and the pressure within the pressure chamber pushes the material down into the soft spots of the silicone, all these micro, and it looks like a tiny little porcupine.
Compared to the other resin, I'd be waiting a while before I can cast anything else and use the pressure pot. So that could potentially slow down the entire workflow.
Okay, so that doesn't make sense because he slowed down his workflow in all these other ways, but he's not acknowledging that the workflow matters with losing a pin on the table, cleaning your scale, changing gloves too many times. Workflow is all the way through the entire process. It's fussy, but this guy's a pro, and if you're a pro watching this, look, people in mold shops don't talk to each other, so how do I say it? I mean, if somebody's willing to share mold making, it's a big deal.
As degassing the silicone for this mold works.
You see, he's restricted on his size of workboard to get in there. I don't know why he does this.
So well, I thought I'd try the same process with the casting by partially filling the mold.
I was never successful at de-airing resin. It just made more air bubbles.
Up to level.
he might be
I think
better
making
at it.
some sort of jig for the vacuum chamber and for the mold would be beneficial, especially if I've got multiple molds, because that means I can stack them.
What's
I
the
also
point?
think I could finesse this a little bit better if I poured into the mold
Okay, so he's using his fingers to push this down. If he had used some little pieces of wood to push this down, his fingers are clean. What's going on?
some precision scales, just so I can get the quantity consistent between each of the parts. While I leave that to cure, I can turn my attention back to the other mold.
This is a really good thing about workflow that I do like about what this young man's doing, and that is that a mold maker is like a chef. You start one thing, you go to another, you come back, because there's all these setting times. And that's why in my shop, there's places for things to cure, there's places for resin to be poured. He's doing everything on one table. It looked like he had a bigger shop, so I don't know why he doesn't have more tables. And my shop is loaded with shelves. I mean, you never have enough shelves.
I need to clean up the slight overflow of resin, then I can back off the machine screws that are holding the inserts in. Then I can open it all up and start demolding.
Okay, so of course it's really pretty, it's great, he's good, but I don't know why his mold needed this fancy case around it in order to make a resin part. There's other ways to scale production with master molds. Then to me it's beautiful, but it's over-designed. Yeah, it's pretty.
Tiny air hole around the opening in the middle of the part, so maybe they do want curing in the pressure pot. So I'm really happy with how clean this has turned out. Obviously I was expecting some excess flashing with the method I used to make the two mold halves separately, but it's just absolutely perfect. It's so clean. I think just some 400 grit around the edge, and that'll be done.
You should have shelves all the way in the back there.
The inserts have worked out well.
A couple mirrors to bring in some light.
I was again expecting some excess flashing between the insert and the silicone, but they're just sitting perfectly.
Oh, that's just.
I mean, I've never done threaded insert.
The other thing is outlets. You know, if you're this skilled, you should have power all over your shop.
It's in a silicone mold before. I did them in the forged carbon mold, so it's the same concept, but no leak through the mold either. So
I'm going to fast through
it's all worked well.
Let's see.
Components I've got. Then I can make a start on all the prep work. This is really a case of sanding all the flat surfaces with the orbital.
Yeah.
I'm using a 400.
So sanding without a mask, sanding. Look, spray booths are not expensive, and you can build a super cheap box fan. You can get a $15 box fan. You can put a HVAC filter in front of it, and you can pull out some loose particulates, and at least those are not getting on your clothes. But he should have right in front of his work table, at the very least, is a draw fan. Those orbital sanders kick out everywhere. I don't know why he doesn't care.
100 grit Abranet pad. Then going around with some 240 grit sandpaper to get the rest of the support.
So this is a lot of finish work for coming out of a mold. I don't understand, because he said he did something one time, he shot blasted it, which is sandblasting to create texture, but now he's sanding back. So I'm a little confused on which parts. He added texture only to have to sand the texture. I don't get it. Here's my opinion on this. This guy is having this really fulfilling moment of being able to try all of these design things, and he's created this fantastic laboratory and school for himself, and he's discovering all of these shortcuts. But if this were in my shop, we'd go broke, because what's happening here is everything is extremely fussy and, in my mind, overbuilt. Now, I'm just looking through his camera, so I don't see anything else. But we would eliminate a lot of the initial design work from the beginning and very much simplify these in every little way possible, from the shop ergonomics to not post-finishing. My guess is this is why people prototype many times. He builds this one time, the next one that he builds, he'll be like, oh, what am I doing? The thing is I don't know what he kicks out. These are sculptures, right? They're not phone holders, they're sculptures. I mean, look at what's going into this. To make a sculpture or an addition is a lot of work, so he has to have a pretty good price point, because I think a creative mind like he has is going to want to be on the next project. It's not going to be spent post-finishing. His skill set needs to be far upstream of handling sandpaper. That's where your assistant comes in. That's where the young guy that wants to learn comes in. So having from A to Z is great, but not from A to Z skills is great, but not in a production sense. You cannot be A to Z production and expect to be as profitable or efficient as you need. But he's one of the few people that I can talk to about mold making in the sense of reflective advice at this level, because other mold makers are watching this. And I think that there's a lot, even with me shutting up, there's a lot to learn here with this guy. But these small things that I'm mentioning, I'm telling you, they come from years and years and years of, oh my God, that little pin was valuable and I just lost it. Now I spent 20 minutes looking for it and then I got to go, to the hardware store to buy a pin? Come on. So these things matter, and there's a difference between a prototype shop and a production shop. And I don't know what a YouTube shop is, how that falls into the beginning of there. Everything he's responsible for, beginning to end. He can start at 9 o'clock, he can start at 5 o'clock, whatever. He's in charge of the timeline. I don't hear him ever mentioning profitability. It doesn't seem to be an issue for him about the hours that go into a part versus you sold it for $400, but you have 40 hours into it. I'm like, seriously? That's not gonna be sustainable outside of a YouTube environment. It just isn't, it's not a teachable thing. So when you make things, design as simply as possible. Remember what your end goal is of that piece. Is it a prototype? Is it for YouTube instruction? Or is it something that you want to scale? Or is it something that you want to manufacture offshore? If you want to manufacture it offshore, get ready. There's going to be a lot of haircuts coming your way. So I'm going to continue to look for mold makers of his caliber, and I'm going to spit little things there. And I know I may catch a lot of flack for rubbing up against a guy who does such a beautiful job at his production. He cares what he does. But where else is the platform to talk about the next level? Because there's a whole nother next level that mold makers that are not teaching are at. They're at the molds of the molds of the molds of the molds. There's so much more to come. And it's a beautiful, beautiful thing. But those guys are tied up in companies. They all have non-competes, non-disclosures. They can't share their technology. I can share a certain amount of mine. I'm only going to go so far, but there is a lot to be shared that just typically isn't. So every guy like this has to invent from the beginning, and it's like, come on, somebody come in with a running start, please, please. So I give high fives here, but I'm going to be a bitch about safety. That's just what you should know me for. I'm going to just be a bitch about it. So I'll get that out of the way and get used to me saying that. But dude, you're a pleasure to watch. I like your work stuff. I would really like it if your shop were settled in certain ways, but it's your shop, not mine. So you are you. You do you. Love it. Thank you for watching this video. We're getting ready to launch a new platform called Hand-ufacturing. It's going to feature a lot more educational films about mold making and casting, from very basic to advanced mold making. Our hope is that it helps the business entrepreneurs out there learn efficient ways to manufacture their products and bring a lot more wealth into their household. Stay tuned.